Hi, everyone. Thank you for joining us at Exchanging Ideas 30 Global 5G Evolution. To the audience around this globe, thank you for participating in this program. And please take a couple of seconds to click the subscribe button on our YouTube channel. A warm welcome to all the speakers around the globe for making it today. And we have a fantastic lineup of speakers, very much to experts in their domain areas. So it will be a very fun and exciting today to hear the speakers to present both on the technological and the business aspect of it. So I'm Ksheeshwaran Govindasamy, the founder of Global 5G Evolution. And without due delay, I would like to present on this case study by Google Cloud and Omdia in the 5G edge computing on the CSP opportunity. Now, defining the 5G edge, the cloud will be crucial in two areas. One, it will be for the enabling of the CSPs 5G networks. And number two, for bringing enterprise 5G edge use cases to life. And Google Cloud works with a variety of CSPs to help imbue the power of the cloud into their networks through techniques like containerization network functions, the CNFs, the software-defined infrastructure, and the network slicing. As you can see here, positioning the edge around different areas, for example, from a microsite, followed by the site edge, the local hosted, and the regional hosted edge as well. Now, if we look this slide, edge is becoming a mainstream fast in terms of the industry, where Google Cloud partnered with the Omdia in a joint study to understand how enterprises plan to use 5G edge. So there was a survey done inviting with a few hundreds of the enterprises. And based from the question that was raised in how are you using or planning to use edge computing services? And based on that reply, 7 out of 10 enterprises expect to invest in edge within the next 12 months. That's good news. And 8 out of 10 believe 5G is indispensable to gain an edge benefits. So the key is that efficiency gains and improved safety are the investment key drivers for the edge deployment. As you see over here, we can able to see for today, the retailers are much more in favor for the edge computing, followed by the manufacturing and transportation. But in the long run, I believe sports and entertainment industry, that was the feedback that it's going to deploy very quickly in the edge as well. Now, if we look in the enterprise network organization, they are leading in the edge efforts. And in terms of the queries that was raised, how is edge computing planned in your organization as well? So it is really promising to see that manufacturing will be the key area where the best to see in this scenario will be features in the smart factory and smart manufacturing. And robotics, I would say stationary robots that build products, mobile robots that move material to and from the production line, and logistics robots that package those products connected through a millimeter wave 5G and URLLC for enabling the data processing and analysis at the edge through the mobile edge computing. Number two, it would be very much into the worker safety as well and quality assurance, the mixture of 2D and 3D videos, computer visions, AI, and 5G will allow this automated quality assurance to be performed right as new product come to the line with the real analytics. Now, if we look, enterprises believe 5G and edge are better together, right? So this is something very critical because 43% of the respondents say yes, 5G has to work together with the edge computing, hand to hand. So meaning to say 5G and edge are both poised to simultaneously improve the performance of applications and enable huge amount of data to be processed in real time. And 5G is very much focused into speeds by up to 10 times at 4G. And whereas mobile edge computing reduces the latency by bringing compute capabilities into the network closer to the end user. Now, this is the edge investment that is gaining momentum across all industries. So the question that was sent towards to the enterprises is, how much do you expect to invest in edge computing, hardware, software, managed services during the initial 24 months of deployment? And the respondent is that those who are willing to spend more than 1 million, which is in the rate, you can really clearly see the manufacturing industry, right? Followed by the healthcare and the energy utilities. But interestingly, those in the sector of, for example, energy and utilities, retail, sports, entertainment, they are much interested to spend on a small amount. So I believe these are the much more smaller organizations which are willing to spend less than 100K. If we look, regardless of size of the enterprises that are investing in 5G edge, for those that are spending more than 1 million, those are those organizations which are more than 5,000 plus employees. And obviously it is, smaller enterprise companies with, smaller employees, they are willing to spend less than 100K. So this is the area where I would like to spend more time here. In terms of the question was, which of these concepts could be most transformational for your organization, right? So, and the question was arise like, okay, is it area of the customers designing their own products and services, or seamless health, security, and identity checks to enter a venue to travel, or customers creating and controlling their own viewing experiences? What are those applications that much related that can be influencing for the edge computing? And the response was, it was in favor into a personalization and customer experience. That was the top priority. And the industry that was favor for personalization and customer experience was the retail, because retailers are looking to deliver more value and gain more customer insights across everything from merchandising to store experience and point of sale. And for personalized shopping, there are many opportunities to evolve the customer's buying experience inside the store, connecting the sensors, integrating the social media, loyalty program details, cloud-based analytics capabilities in near real time. The other area is the videos to improve the customer experience, because waiting in any time is never a good customer experience, and the ability to minimize the lines and wait times will be a real differentiator through the use of video and applying AI to the video feed, so that the store managers are alert that there are queues and they will try to improvise the operational activities of the workers so that they can able to allocate the workers at the right locations, so on and so forth. And lastly, this is my last slide. I just want to just clearly mention here that real-time insights from the cognitive analytics are driving the 5G edge adoption. So, and as you can see, this particular table, this where you can able to clearly see that video cognitive analytics, dominates compared to the other applications. And it is very clear that business intelligence and automation deployments will be more than double in the next 12 months. Surveillance and transactions cognitive analytics are most widely deployed. And also data storage side mirroring continues to gain the momentum. So this is the overall my presentation as the first part. Next month, I will be continuing as in the part 2 to go more clear depth of the CSP opportunity. So thank you for the time. So let me pass on to the next speaker. I would like to introduce Dr. Marcin 𝗦𝘃𝗽𝗃𝐺𝗫 from Poznan, Poland, to present on the 5G Open RAN. Over to you, Dr. Maciej.
Hello, can you hear me? And
Yes. Yes.
see the screen possibly now?
Yes.
Okay. So thanks for the introduction, Kanesh, and for having me here the second time, I believe. Welcome everyone. My name is 𝗦𝘃𝗽𝗃𝗽𝗃 and I'm the CEO of and co-founder of 𝗦𝘃𝗽𝗃𝗽𝗃, a spin-off of the Poznan University of Technology in Poland. We are a research and consulting company focusing on wireless communications, currently on Open RAN, mostly 5G and beyond. And the discussion today is on Open RAN 𝗬𝗹 demonstrator. As we already had a chance to discuss Open RAN as such, today I'd like to touch upon the demonstration and the 𝗬𝗹s themselves. So just a quick recap. In ORAN, I'm not going to go into the details here. The most important aspects I want to touch upon are the 𝗬𝗹s, so the yellow parts in this figure. The 𝗬𝗹s related to the near real-time rig, the controller sitting in the RAN domain, and the RAPs sitting in the management plane corresponding to the non-real-time rig. Those are the algorithms that are controlling the behavior of the RAN. This is where we could split the, let's say, the incumbent vendors from the new parties that could develop the 𝗬𝗹s to work on specific algorithms. Focusing on the RAN intelligent controller in a little bit more details, and those 𝗬𝗹s and RAPs. Those are algorithms such as, for example, traffic steering or quality of service management or interference management or connection management related to the radio access network behavior. They are controlling the base station itself, also called E2 node, the central unit or distributed unit over the E2 interface. Over or with the latency of around larger than 10 milliseconds and less than 1 second. And the other types of applications or third-party applications are RAPs that are stored or connected with the non-real-time rig that is sitting in the management plane over a WAN interface, providing the policy and RAN analytics and mostly the AI ML model training with the latency of larger than 1 second. So rather dealing with the trends in the network, speaking about functionality like coverage, capacity optimization, and things like that, or energy saving management. So speaking about those different types of apps, today we're going mostly to focus on 𝗬𝗹s. So they are an application designed to run on the near real-time rig, again run in the RAN domain, and it is independent application from the actual near real-time rig. It might be provided by the same company. So if we have a near real-time rig from Nokia or VMware or Mavenir or Accelerant, they might have their own 𝗬𝗹s, or it might be provided by a different separate party like 𝗬𝗹 providers. The important aspect here is that the 𝗬𝗹 itself enables a direct association of the functionality in it and the RAN functionality inside the base station, right? So we have, for example, traffic steering functionality or traffic steering 𝗬𝗹 that is related to the connection management or to the radio resource control in the actual E2 node or central unit, or we have a different 𝗬𝗹 that is scheduling control, and it's related directly to the distributed unit where the actual MAC scheduler is sitting. And the RAPs are more of a providing policy-based guidance. So based on that, we could say, for example, that we would like a certain type of user to be controlled or be connected to this or that type of the cell, instead of directly sending the command, where the 𝗬𝗹 is sending the actual command to invoke a handover operation or something else. So that would be a long story short, getting into the actual simulation. So I'm going to go into the, let's say, live demo here with a simple simulator that we have to show the operation of those and the different things we could be able to control with those kind of XApps. So if with our scenario, we have a simple toy scenario with macro site and multiple small cells with 2 frequency layers and 2 types of users, the voice users and MBB users. The idea is to serve those without an outage or with minimization of the outage, so fulfilling the quality of services for both of the types of the users accordingly to their requirements and the services they have. So in the setup, we have the rig that is controlling both the macro sites and small cell sites. And we have 3 XApps, the traffic steering XApp that is assigning users to the cells. We have quality of service resource allocator that is assigning resources to the users once they are connected to the cell. And then we have frequency band selection, which basically decides which frequency shall be used for those users to, let's say, based on the operator's requirements and the actual needs. So for example, if we have, I don't know, low traffic, then we switch off some carrier, or if we have high traffic, we switch on more carriers, or if there is a, let's say, cheaper carrier like unlicensed spectrum, and we don't have as much requirements on the quality of service in terms of, for example, throughput or delay, then we also might switch off the licensed band and use unlicensed band. So this is sort of the setup, and now let's move to the actual demonstrator. So we have, let's say, given an open access to a tool that enables to go over the website to get access to the actual demonstrator. And it's, let's say, having certain set of setups to configure, as well as certain outputs, including the network topology. So here we can see those base stations with the corresponding parameters. Users, we can switch on, let's say, movement and dynamic behavior of those users. We can increase the number of users here. For example, change their required throughput. That will change those values here. And then the assumption or the idea is that we would like to assure that the outage is minimized. So here we can see what's the actual outage of the different types of users. We can see that most of the MBB users are not satisfied with the throughput they have. We can also see the distribution of the users to the cells, which pretty much is sort of random in the sense that they are connected to the cells that they are closest to from the radio perspective. But then we have those 3 XApps that we just discussed. If we use, for example, traffic steering XApp, then we can see what is the actual policy that is used from the A1 perspective. What's the actual policy type here, meaning that it's default. So we are just using received signal power to associate the user with a cell. While if we, for example, offload or apply an offload traffic, then what we can see is directly that the MBB users are rather connected to the small cells, and that is reflected in the actual policy and the, let's say, a JSON format. And also in a text format that the small cells should rather avoid using or connecting the voice users and rather focus on the MBB types of users. We can also switch on the machine learning engine that will decide which frequency, which policy shall be applied. And then over time, when things are changing, then we can see that, for example, a different policy is, in this case, default is the best one, or offload is the best one to assure that the best possible association is used. We can also add the second XApp, which is quality of service based resource allocator with its own policies. So it has a different types of policies that will distribute the resources to different users differently compared to the default setup where everybody gets pretty much equal configuration yeah, things like that. So this is sort of, we can of course switch off the TSXApp and focus only on the allocating resources based on the current association of the users. So in a slightly different way, make the same thing happening, basically making sure that the users get the required throughput they need. So the idea in general is that we show how those different XApps are influencing the resource allocation, the outage, and making sure that the users have fulfilled the SLAs. So with those, we currently have 3 use cases being addressed with the traffic steering and then quality of service based resource allocator. And then currently in the coming days, we will have the massive MIMO optimization use case already available also in the same tool. If we are looking at the technical priorities, also from the operator's perspective, those are the ones that they show they're of high priority for being addressed in the ORAN case from the XApp perspective. That is the next one that is not yet available, but will be available soon on the beam mobility management, to making sure that in the massive MIMO cases, we have the allocation of the particular beams to the users, specifically in a high throughput scenario. So to summarize, because I think we are already off the time, the main aspect here is not to sell this. This is not a marketing, let's say, discussion. It's more of enabling and showing the potential of the different XApps, that we can increase them and then visualize their impact on the actual network. And also things like, I don't know, conflict mitigation. If we have multiple XApps that will be conflicting, that's also one of the discussion that is very important. How to make sure that we have a stable network and not the one that is ping-ponging if we have, for example, mobile handover and traffic steering and then load balancing working together. That tool is for free, so everybody can use it to see and, let's say, visualize themselves how having the XApps and having on top of that machine learning could help to improve the SLA and the overall outage scenario in the network. And then finally, the next XApps are under development, as we can see the massive MIMO case, but we are also going to increase, let's say, or expand on the traffic steering scenario with energy saving use cases to make sure that we are addressing those aspects that are currently being discussed within the ORAN Alliance case. So with that, I would like to thank for attention, and hopefully I didn't take too much time.
Thank you, Dr. Marcin. That was a brilliant demo. I have some questions. Let's have it to the end. For the next speaker, I would like to introduce is 𝗦𝘂𝗽𝗽𝗃𝗽 from Amsterdam, Netherlands, to present on the smart supply chains with 5G and MEC. Over to you, 𝗦𝘂𝗽𝗽𝗃𝗽.
Hi, everyone. Good afternoon. Good morning. Let me share my screen. So can you all see my screen?
Yes, sir.
Okay, great. Hi, my name is 𝗦𝘂𝗽𝗽𝗃𝗽. I work for Verizon. I'm based in Amsterdam. I'm a solution coach or distinguished architect, as we call, in my current role. I support large clients with the 5G solutions and use cases if they are planning to take on 5G and edge compute journey. So I work with the different clients. This is not really a product pitch or something. It's mainly to share some of our insights based on our working experience with different clients. We also published a white paper on this topic. I authored it together with my colleague. So I'm going to share some of the details or some of the frameworks that we came across in logistics with 5G, where we can add extra the futuristic solutions. And yeah, that's the context. And there are so many use cases. It's more of a use case driven exercise. So the key factors what we have observed in the context of supply chain industry. If you remember that famous block of evergreen that that disrupted the entire supply chains, and also we had COVID, during which you had a lot of online shopping and things for like even groceries you are trying to get online. Everything different. For consumer behavior, more demand stress on the existing supply chain. Some of them could not withstand those stress, and so it's very it was one of the important driving factors that affected supply chains, and how they have to relook at and refresh, and be more resilient for such changes. And second thing is there is already a requirement for container tracking management, predictive analytics, but the consumer side and also for the manufacturing side or supplier side, both of them, they want near real-time insights into where this product or where this shipment is, and if it's in the production facility or warehouse, where in which location, what's the inventory. So they want all that information. That will help them to optimize the production process and logistics or just in time processing, all those things. And the third important thing is the compliance requirements. So where you should send, where you should not send, are you able to track some specific materials? If it's some drugs, for example, you want to track the compounds, which are one, you keep the integrity of the material. At the same time, you also want to ensure it is tracked and according to the compliance requirements with local laws and embargoes. So these are the three key factors that we saw driving supply chain industry. And based on that, we sort of understood or tried to put it in a framework. So which, as you can see here, you have a production facility, and then you have distribution, transportation, and delivery. These are the four main aspects of supply chain. And here these are the normal four steps in the supply chain. And what is modern about it is what you see at the outside the circle of each function. Like production facilities are fit with a lot of sensors now. There are a lot of IoT solutions deployed there. OT environment. If it's in the mining environment, you have automated guided vehicles, and you have virtual reality or predictive maintenance in the production facility. And then when you go to distribution center, you have AGVs, and then you have surveillance cameras. I have one use case. One of the customers, they wanted to, there was a big warehouse, and they want to see the wine bottles. The employees were taking some of the wine bottles, carrying them, and they wanted to, keep them not in a way intrusively checking, frisking every employee, but they want to passively monitor that, those kind of things. And they use computer vision for that. So computer vision is a phenomenal transformation technology that 5G or edge will bring to change a lot of what we can see with our naked eyes. You can use your normal eyes for entertainment. You can watch movies. You can also monitor something. So you can do all those things exactly like you use a dumb camera and with smart intelligence on the edge. Then it goes to transportation, and transportation has different ways. It can be in a plane, it can be on a boat, it can be on a train or container. Each of these mediums have their own connectivity. So because if you want to track seamlessly all these four mediums, and if it's on road, if it's on air, it's important that you have overall framework that has that will give you that kind of real-time visibility. And delivery is the last stop where you actually deliver to a business or deliver to a person, like individual, right? And one of the things that you have seen with the growing e-commerce, you have to have the very like a robust reverse logistics. It has to, if somebody is sending things back and forth. So all these touch points with I would call digital touch points provide some data or information, the footprint, what they call, and everything is collected and analyzed to get contextual insight. That's in the center what you see, predictive analytics. So the overall idea is there were technologies like to automate this entire process. We use computer information technology, all those things. But with the advent of 5G and edge compute, 5G brought that, it actually broke that ceiling, glass ceiling of limitation. So the kind of data that you can transmit, especially for use cases like computer vision or AGVs, you have or AR, VR, these kind of use case applications, they need a lot of data that actually now solved by 5G. And okay, you have a big pipe which you can transmit lots of data. Then what can you do with it? So that's where comes the edge compute, where you use the we work with a lot of partners, AWS, Azure, and Google as well. So we work with them, and then these platforms that provide the solutions run on the edge, which will give you all the benefits that you see in the next slide. So to summarize this slide, the modern supply chain environment is really complex, and you need to have a mechanism to optimize your processes and manage your costs, because the margins are tight. There is unforeseen demand. Suddenly it can go up and down, and then it should reverse logistics. All those things, they cost you a lot. But if you have a very reliable infrastructure underneath, which provides you the ubiquitous connectivity and also data points that you can actually use to define your process. That's this slide. So with this, what we found out, we did a little bit of research with other people who are involved in this domain. So there are three topics that are mainly affecting. So one is the applications at the edge, so that are very important for the smart logistics in the context of Industry 4.0, where you have the network sensors, then you have the robotic arms in the production facility, drones, AGVs, computer, all these applications. Each of these application demands, or each of this is an IoT application, which is running on a platform. So as you all know, the IoT each service is more or less delivered as a separate platform, and all these platforms should run somewhere. Normally they run it on a cloud. So enterprises prefer, for many reasons, they want to run it on premise, and edge is the perfect place because it gives you that control, and it gives you that low latency other demands that are from the context. Then you have the application-based network optimization. This is very what we have seen. People want, enterprise especially, they want for a specific application, they want to define the quality of service. And then for different reasons, some applications only need latency, low latency, some applications need the bandwidth, depending on the specific requirement. People are looking for such a feature actually. And then the network slicing. I don't know, Marcin, what you presented earlier, it sounded more like a network slicing, which why I asked you that question. A network slicing is a very important feature for the industry, smart logistics, because they can specific applications dedicated bandwidth and service.
Hi, Bharadwaj, the time was over. Are you able to wrap it up quickly?
Yeah, okay. So there are a number of use cases. Like I said, it's all use case driven. The cool part is you can set up this infrastructure on the core level, and then you can deploy. You can use the same infrastructure for multiple use cases, and that will transform. That is not just automation, just transformation of the logistics entire end-to-end. That was my time. Thank you.
Thank you, Bharadwaj. That was brilliant. Appreciate that. Moving on to the next speaker, let me introduce Dr. 𝗃𝗃𝗽𝗃𝗃 from 𝗬𝗂𝗃𝐺𝐵, Turkey, to present on the disaggregated near real-time 𝗚𝗏𝐼𝐶 control plane with unified database. Over to you.
Hi, everybody. It's a pleasure to connect with you all. This is 𝗦𝗃𝗃𝗽𝗃𝗃𝗃, and this is a research paper will be published on IEEE Explorer probably next week, and written by me and my colleague 𝗦𝗃𝗃𝗽𝗃𝗃. We are focusing on 5G research. And this was already presented in 𝗬𝗃𝗃𝗽𝗃 2 weeks ago, and now I will be presenting it to you. It is about disaggregated near real-time control plane, which works with unified 5G database for network slicing, MEC, and NWDAF integration. So, as you all know, the use case of RAN controller with MEC, network slicing, and the WDAF integration is one of the key enablers for 5G networks to function for the 5G networking. Previous speakers already mentioned about O-RAN architecture. Marcin mentioned about the XApps and RApps. That was a great brief before this. So O-RAN architecture is expanding SDN controller concept by decoupling the control plane and user plane, by enhancing the traditional RRM functions. However, looking at the already mature concept, software-defined networking, disaggregating the control plane and data plane is not enough for integration of the key enablers. So probably MEC, network slicing, and WDAF peering inside RIC will be delivered by the combination of RAP and XApps, and they need to work together. They need to understand each other in terms of data flow. So disaggregating control plane itself also will help RApp and XApp developers to build end-to-end and integrated solutions. So in this IEEE paper, we proposed an architectural perspective focusing on near real-time RIC with its disaggregated control plane enhancements. So Marcin already mentioned the architecture of the ORAN. As you see, there is SMO on the top, near real-time RIC on the middle, and E2 nodes controlled. So I won't go through this again because he explained it this in detail. So I will jump into the enhancements delivered by this paper. So our main motivation was looking at the more mature concept, which is software-defined networking, focusing on open flow. So you see SDN architecture on the left-hand side and the ORAN architecture on the right-hand side. If you look how they are mapping into each other, that we see application layer in SDN architecture, control layer, and data layer. And similarly, SMO and near real-time RIC and RAN, if we look at the mapping together. As you can see, our apps and XApp combination can be delivered as SDN applications and business applications. And if you look into the SDN controller, it is in the two pieces can be delivered in non-RT and near-RT real-time RIC. So, as I mentioned, SDN is more mature technology because disaggregation started to happen in the core. It was initiated by Stanford OpenFlow and then enhanced by work from Google. And if you look into those enhancements, disaggregating control plane and user plane from each other is a great start for scalability and O&M perspective. But to be able to deliver our app and XApp combinations, we also looked into how we can disaggregate control plane itself. So looking at the control plane inside near-RT RIC, we see elements like O1 termination, A1 termination, XApp lifecycle management, platform database, which has RNIP, UNIP inside it, XApp subscription management, and API enablement. We see E2 termination and conflict mitigation components. So as you can see here, we have enhancements in orange, green, and blue colors. Actually, orange, the one on the top is representing northbound interface. The one in the bottom, which is green, is representing the southbound, and the blue one is representing inter-process enhancements. So those are focusing on how these interfaces can communicate with each other. That way, the data is transparent so that different XApps and our app solutions coming from different vendors can work with each other. So in here, O1 termination service interface should convey data for translating netconf to the APIs. NBI should define PM, FM, and provisioning management. SPI should define the netconf to manage XApps. And all the definition of this data should be standard so that all the SPI, NBI inter-process connectivity between internal modules of near-RT RIC control plane can talk to each other. Similarly, A1 termination NBI should convey the data for policy identifier, policy type, and other related policy-related information. SPI should define the mapping between policy and the policy received from non-RT RIC. And in addition to that, AI job also needs to be mapped to requesting XApps. So I will summarize and a little bit jump between details. If you need more details about what kind of data can be communicated between those interfaces, it will be in the published IEEE paper soon. So please reach out to me, and link will be available soon. You can find out more details. Again, except lifecycle management and other components have information to talk to each other for the MBI, SPI, and interprocess. So on top of this enhancement, we looked into how we can show an example of MEC network slicing and NWDAV integration. So previous speakers already mentioned why MEC is critical and why we need network slicing. Of course, you all know. NWDAV network data analytics function is important so that it can carry analytics information and provide AI-enabled statistics to the producers and consumers so that all these different authorities can decide with some integrity coming from central analytics. So looking on the picture on the right side, we see a manager tools runtime DB. So we can have different orchestrations from different vendors, a slicing manager coming from one vendor and MEC manager other vendor and other management tools. But with this standard definitions, they can all talk to the standard NW collected data, and the produced will be delivered to others. And if you look at the non-real-time runtime DB and near real-time runtime DB, you will see the corresponding data flowing for slicing MEC and NWDAV in here. All these details are in the paper, so you can reach out to those details. It will be hard to cover in 10 minutes. So looking at this here, again on the top, all these orchestration tools like MEC Manager, Network Slice Manager. And when we first get the network slice SLAs, they will be converted into Nest, which is a network slice template, will be consumed by the slice manager. And all these components will translate these needs into the different domains, which is RAN, transport, and core. This will be happening via CSMF and NSMF. And all these controllers will receive the need from the network slice manager. And those will be communicated to non-arteritic and near-arteritic via the XAPS and RAPS combinations. So I don't know how much time I have, but if you look at in the 3 steps, step 1 focuses on the NW DAV, NEC, and MEC manager coordination. At this point, it is very important for them to talk to each other so that there is a single source of authority. It is very important for conflict mitigation, because if MEC tries to adjust resources without communicating with RIC, and if any network slicing or manager tries to do something without MEC authority and RIC, then they are going to create some conflict, which will be very difficult to troubleshoot. So that's why they need to talk to each other. And this will only happen by disaggregated near-arteritic control plane, which I explained in the previous slides deck. So step 2 focuses on the non-arteritic RAPS, where they receive NWDAV statistics. And it's critical at this point to have unified 5G database. As I mentioned at the top, we need to have single source of authority. And for data, we also need to have single source of truth. This is critical because we have standards creating the data from different parties, but they have different granularities. They are received by the different timings. It is important to have those all in unified 5G database, which is again explained in detail in the paper, so that we can have single source of truth, which can be consumed by these all MEC and NWDAV and network slice managers. That way, we are helping those tools to have the single source of data and authority. Step 3 focuses on you. Okay.
The time was, yeah.
Okay, guys, if you need more detail, it's on the paper. So thanks for listening. Hope to see you getting connection about the details. Take care.
Great presentation, great help, great support. Thank you, Dr. Hale. I appreciate that. So let's move on to the next speaker. I think there's a little change in the agenda because I just heard that Azim had a family emergency. So I got to slot Azim now. Let me introduce Azim Tari Mahmoud from Cairo, Egypt, to present on the 5G Open RAN.
Hello, everyone, and I really apologize about the unprecedented change in the schedule. So please let me introduce myself. My name is Hazem Mahmoud. I work for Dell Technologies, Senior Consulting for Telco 5G Open RAN and Private Mobility. Okay, in this presentation, I will take you through three main topics with regards to the 5G Open RAN deployments. Okay, it will be very simple, very light, a little bit far away from any sophisticated technical details. We will answer from deployment perspective and consulting perspective the questions, the major questions for how and why we deploy 5G in Open RAN manner. Okay. First of all, according to the latest market directions, usually 5G deployments are brownfields. Here we can demonstrate how can brownfield telco make a transition to Open RAN. First, the transformation of the operating model. If brownfield operators plan to adopt Open RAN, they need to transform their existing operating model completely by restructuring to the organization to enable scalability of Open RAN deployments. The second point is process re-engineering. The existing processes and framework needs to be redrafted to support the integration of multi-vendor environment and guarantee its interoperability. The third point is being cloud native and automation. The operators should mobilize new capabilities to move to a more futuristic network based on cloud native solutions and more industrialized level of automation. Finally, and more importantly, new talent and upskill the Open RAN deployment requires Open RAN operators and CSPs to hire and upskill their talent with new technologies, including cloud computing, automation, CI/CD, infrastructure as code, and more to the operator network. Next. Now, as we all know, the bigger the challenge, the bigger the opportunity. As deployments have rolled out, system integration has been needed to validate and operationalize these end-to-end solutions because they converge challenges across multiple layers and multiple domains, including radio, transport, core, cloud, data management, application, services, security, etc. Here's how below the key lessons learned from industry's best practice. The first point is scale matters. I name it scale matters because size and scale prove to matter when handling Open RAN integration to accommodate the desired hyper-diverse 5G use cases, especially in the standalone 5G environment. So operators that select system integrators with domain expertise, deployment experience, and scale have the greater opportunity to succeed. The second point is testing is critical. Open RAN standards are in fact open. New vendor products must be rigorously tested for standards compliance. When it comes to 5G deployment, it takes, I would say, extensive infrastructures and proficiency to conduct use case testing, system validation, performance testing, environmental simulation, and more and more. The third point is product development. 5G, we can say it's a device-to-device technology, not a business-to-consumer. I would say it's a device-to-device because it's use cases. Okay, where understanding of product development and design approaches will be a great asset to roll out 5G Open RAN network, especially for mission-critical services. Last thing, and more importantly as well, the lifecycle management and orchestration. Once an Open RAN solution has been deployed, lifecycle management becomes necessary to constantly update, upgrade, fine-tune, and improve the deployed solution. Next, why Open RAN is critical for maximizing the value of 5G? Or in other words, why do we need Open RAN in 5G deployment? With regards or in comparison to the legacy vendor or the incumbent vendors, why do CSPs move and needs Open RAN in their 5G deployments? Here we can talk about three main reasons. The first one is a cloud-native software-based RAN infrastructure or architecture to address the speed and latency needs of emerging innovative services. 5G network needs to support a strict quality of service requirements to provide a differentiated experience and support new services and industry verticals. At the same time, with the introduction of technologies such as software-defined network function virtualization, and network slicing, networks are becoming increasingly flexible and programmable. Yet, with these benefits also comes the necessity for extreme automation of services and network management and more, as you all know. This is where 5G open network architecture becomes a necessity. The second pillar here, or the second topic here I talk about, is the automation, DevOps, zero-touch provisioning, CI/CD pipelines. Open RAN, as you all know, promises the remote automated software installation, promises the zero-touch provisioning, test, validation, rolling updates, upgrades using CI/CD pipelines, and ultimately, self-healing, self-optimizing networks using analytics and other AI operation features, with many solutions relying on Kubernetes ecosystem for configuration and orchestration. So by leveraging open platforms and new methodologies such as DevOps or fast iteration, this will maximize the value of 5G and creates new opportunities for the CSPs. The last thing here is the open interfaces. As you may be aware, all of the 5G deployments today are 5G non-standalone deployments. So this is the majority, not all of them, but this is the majority. So if the X2 interface is not open, then the CSP or the operator are forced to deploy 5G on their existing LTE vendors. Hence, the lock-in continues into 5G as well. So open interfaces here would be very helpful in such scenario. The last topic here I talk about is what is the next chapter of the Open RAN? What is the market direction for the Open RAN? Okay, the first pillar here I talk about is the management and orchestration. Automation is the provisioning of hundreds of thousands of bare metal servers, which needs a very sophisticated orchestration tools. Open RAN is evolving rapidly, so implementing a CI/CD model will help to migrate testing, integration, software releases, and actual software deployment of the RAN. So remote development and software deployment as software push to hundreds or even thousands of sites. This will be a necessity. So now the RIC or RAN Intelligent Controller, as an example, enables intelligent orchestration of RAN resources through modular microservices and open interfaces. The second point here is interoperability, standardization, and certification. The 5G and Open RAN revolutions are unfolding simultaneously, unlocking a new world of possibilities, mastering the Open RAN's testing requirements, and using integrated solutions to perform the necessary testing and critical to your success. Me here, I am speaking as an operator, as a CSP. So many vendors now are building their own labs for these purposes. CSPs are heading to the most successful system integrators who has their own labs to validate the end-to-end solution for their Open RAN. The third pillar here And as you know, the future of Open RAN is in the enterprise edge. Open RANs is open interfaces. This will continue to simulate innovation from smaller vendors who are challenging the vendor lock-in associated with the latency, with the legacy macro network suppliers. These new entrants are supplying an increasingly diverse range of radio units. This will help drive the private 5G market forward with solutions suitable for both mass-scale private enterprise use cases as well as custom-made high-end use cases for many vertical applications and industries. The enterprise edge services market is expected to feature many greenfield applications and opportunities: 5G, software-defined network, Open RAN, disaggregation, virtualization, and cloudification are very, very essential technologies for enabling state-of-art 5G connected edge platforms and deploying a wide range of enterprise services. Finally, fostering some vertical applications such as remote surveillance, predictive maintenance, shipments remote monitoring, and more and more. The last pillar here is infrastructure as code, which is, I would say, leveraging the CI/CD, continuous testing, continuous delivery, continuous qualification methodologies while integrating an end-to-end Open RAN ecosystem. Thank you. This was my words to you. I hope I get it short and brief. I hope that I reached you all. So it has been a privilege for me to be among these amazing lineup speakers, and looking forward for more engagement between all of us. Thank you. Thank you, Kanish.
Thank you, Azim. Appreciate it so much. Now, moving on to the next speaker, let me introduce 𝗃𝘃𝗽𝗃 from 𝗃𝘃cie, Slovakia, to present on the live digital twins. Thomas, over to you.
Hi. Hello, thank you. Can you hear me well?
Yes, sir.
Okay, good. So today I'd like to talk about a little bit about live digital twins, what it means, where we goes, and how it connects to new development in 5G and other topics. Because first, what the live digital twin is, you may be knowledgeable about the digital twin term, which is very broad. Nowadays there are lots of digital twins out there, including reality capture, light and photogrammetry scan, a lot of big data capturing solutions, and they all claim to be a digital twin. Then you have another section of simulation tool from Siemens and others who also claim to be a digital twin. For us, it's all a progress. So you start with the representation, then you move towards simulation, and then there is the operational side, which we try to adapt a live digital twin to show its place in the life cycle. So let me share a screen, and I will show you what it means. Okay, share screen. You should be able to see my screen and my phone. So we created a platform that's called 𝗃𝘃𝗽𝗃 to rapidly develop and deploy live digital twins. The application is actually free to download from App Store on Android and iOS, and also for Windows. So you are free to try it yourself. And yeah, we operate on a global scale because most of our customers are global corporations. And I will show you a few examples what live digital twin can mean and how it relates on the latest technologies that are deployed within different type of facilities. So what you are looking at now currently is a facility here in Slovakia. It's a few hundred kilometers away, and this is a real-time overview of a manufacturing facility of a Whirlpool factory, where they have multiple sources of data connected. One of the most important is live logistics. So you are able to see in real time, the position of every forklift in this facility. You are able to see, you know, where he was spending how much time and what he was doing since the 6 a.m. and basically replay the whole shift. But also you are able to locate other data such as production information to see, well, okay, we don't have any data from there yet. They are not sending, so we'll get to this with another use case, because it all depends, and this is a key topic on the data connectivity. Within this particular use case and customers, we do have a lot of issues with data connectivity, as they are running on legacy systems, especially. So from time to time, you are getting, you know, no data, as you are able to see here. So what we do with most of the customers, we are trying to help them, one, provide a vision where they are able to get like to this part of visualization that enables you to understand the data as they happen, but also to show them a path how to get that real timeness in it, and with very low latency and very high dependability. So with these legacy systems, we often see, you know, this blackouts of data. So where we see this on a larger scale, and this is exactly the topic that we get into quite often with our customers, is how to make it work in a bigger size. So this facility is from the company called Škoda, where they have many different buildings. It's 2.5 square kilometers big, 25,000 people work there. And we currently have one production hall implemented, but within the site they have many other buildings that we are going to roll out, and they need to visualize more than just, you know, position or manufacturing data, but also, you know, where the drinking water is, where the compressed air, where the heat is, where the electricity is, and all of those sources can generate tremendous amount of data that needs to be captured and transferred. And especially in this type of use cases, we see a lot of benefits in, for instance, private 5G networks that can support this type of large IoT deployment, because to monitor everything within space, you need to have, you know, a lot of sensors, a lot of data, a lot of things around the facility deployed to actually get to the live digital twin. So within this facility, they of course monitor, you know, production, so high level information about, you know, the production speeds and KPIs, but they also added, you know, temperature readouts, so IoT. Then waste management, or again, can be IoT, because now you have a placement of every bin with the information from bin management systems, you know, when it disposal collection, what's the status. Then you are able to correlate it with, you know, is the logistic gate open or not, another IoT source of data that we need to get the information in. And overlay that, for instance, with heating system, like where are the pipes, where are the exhausts, what is their condition from different systems. And then it can be used for visualizations of abnormal states, you know, correlation analytics, looking towards how to optimize process, not only from the manufacturing point of view, but also from the facility management point of view, because they all correlate and connect together. And this is what we are helping our customers to realize, that that all of that information that they have and they are trying to get, they correlate to each other because they happen in the same space. And they need to be able to understand where are the correlation, where are the causalities, what is the difference between optimal process and the one that we have. And live digital twin can exactly help with that. Other than that, and this is a showcase part that you can access on your own, we do have a presence in smart office space. So the same principles as we use in manufacturing space can be used in office spaces. Again, you are able to capture, you know, real-time position of people. You are able to see condition of the meeting rooms. You are able to see, you know, what's what, how's there. You are able to, integrate smart parking sensors into the solution, and you are able to provide a tool for, guide paths to exit strategy and lots of different data that can be merged together. So both IoT, existing system, and building information spaces and building information systems together with this live overview and orientation, so the users of the facility can get most out of the facility itself. And the same can work for hospitals, for small offices, and even for the cities. So smart cities is picking up as the cities are adopting these new technologies. They already have the coverage of 5G networks, but they also implement, charging stations around the city, and you need to be able to monitor which is running, which is connected, which has a problem. If we need to do something with it, what's the current consumption? What is the condition of different parking lots around the city? Where are my greens? What's the water consumption? Where are main pipes of the sewage, of the gas, of the water? Where is the electricity? Where we have transformation pillars and lighting columns? What's the condition of the lights and lighting and different junctions? So yeah, what's the current condition of a smart street light? And all of these smart technologies are being added to smart cities without mission control to actually monitor everything that is easily accessible by regular humans. So this is what a live digital twin can help you. And the cool thing about the twins is we also recreate the data sets on the background. So we connect everything through the 3D space and time, and that enables us to do a lot of cool analytics in the background. We are able to provide this data set to AI and machine learning algorithms. We are able to do correlation analytics. We are able to run autonomous logistics based on this understanding of a space. So this is a quick overview of how all of those IoT and system data can be connected together into the live digital twin. But for that, you need to have IoT deployed, you need to have a systems deployed, and you need to have a way to connect them reliably to the platform. So we always rely on what I call an underlying technology that enables us to actually work with the data.
Thank you, Thomas. That was brilliant presentation. It was great that you came up on a last minute call. I really appreciate for your time. This was so useful and really helpful to the audience. Appreciate it so much. Thank you so much. Thank you for joining us. So moving on, let me introduce the next speaker, Chris Southgate from Singapore, to present on the digital transformational at the age empowered by 5G. Over to you, Chris.
Thank you. I'm just checking to see if you can see my screen.
Yes.
All right, great. Thanks again for having me here today. Pleasure to share with you around digital transformation at the edge. Chris Southgate from Microsoft. I'm based in Singapore, but I have a global remit. So at Microsoft, we take a multi-horizon approach when we're having conversations with customers around their adoption of edge and edge technologies. As you know, edge is quite nebulous. The definition of edge is quite nebulous still. And so that definition is still sort of being worked out by, vendors, hyperscalers, customers, and we're all in it together and trying to figure out what that actually means. And as we've discussed today, edge is, there's a 5G component of there. There's also IoT. We just talked about digital twins and OT, right? So when we look at it, we're really looking at sort of like a North Star, and the North Star is an intelligent powered edge. And what that really means, it's an accumulation of Horizon 1, Horizon 2, and then getting to Horizon 3 standards, right? So this is really where we want to go. And it's like I said, it's a multi-horizon approach, but it takes time to get there. It's not something that happens overnight. It could take several years or several months to get there. The technologies are all evolving as we go along, especially the OEM providers around 5G. There's been constraints that we've seen around silicon, right? So we don't really have native 5G UEs at the moment, or not at least mainstream, let's say 5G enabled cameras or sensors. So it's trying to come up with sort of that mixed type of environment. So when we're really looking,
I have to hold you, Chris, just to check. I couldn't able to see the slide. You haven't shared yet.
Oh, I'm so sorry. Let me share again. Just bear with me a moment. Let's see if we can get this. Okay. Can you see the slide now?
Yes, now it's perfect.
All right, great, thank you. So yeah, so this is the multi-horizon approach, as I mentioned, and we're kind of looking at that North Star, so the upper right-hand side there as well. Now, when we look at Horizon 1, we're kind of looking at sort of the standardization approach. So how we help our customers around standardizing their OT and IoT environments, but also standardizing their data integration and ingestion into their maybe on-premise data sets, and then looking at more like a cloud or even an edge compute. So that multi-edge compute then comes into play around hosting data, right? As you sort of go into Horizon 2, which is the modernization phase, we're then sort of ensuring that we're getting all those disparate data sets. So even like insights from certain sensors or devices. Let's say in a manufacturing plant, it could be a sensor on a robotic arm or a camera, for instance, and we're centralizing those insights to give a real sense of what's actually happening on that particular site or in that environment. We then start looking at like maybe IoT hub as a centralized data store. And then as we start progressing more into the digitalization phase of the Horizon 3 stage, we start looking at other technologies. So something maybe like HCI or Azure Stack Edge components, and these have maybe like GPUs based into them. So we can really take some of the benefits that you'd get in cloud, get a subset of that, and start bringing it closer to where the data is being ingested in and where our customers are meeting their customers. And part of that is obviously, when we get that compute power at the edge, we can also start looking at low latency aspects as well. And this is where really with 5G comes into play. And when we kind of start looking at 5G, it's not really, okay, well, the sake of 5G, this is really being driven by the ingestion of data. So as sort of the need for data and data ingestion grows, we're going to sort of open up that pipe. So think again as a freeway. Before we've got a small little country path with our internet-based connectivity back into maybe a hyperscaler. But as sort of more and more data points light up on premise or at the edge, we then start going, okay, we'll need 5G. And some of the big workloads that we've noticed that sort of start coming out, especially in those use cases, right? I sort of touching on a little bit is intelligent vision. So, capturing images, looking at that imagery data as well and trying to get insights out of that. And then as that evolves into maybe more autonomous vehicles, And that then lends itself to low latency, high bandwidth use cases. So for instance, you've got a forklift, it's going down the aisle of a plant, a box falls off a shelf, that vehicle needs to identify, hey, there's an obstacle there, I need to now work out my shortest path. It could literally be on the other side of that box. It will work it out quickest path to where it needs to go. And at the same time, it will kick off a workflow that says, hey, this box has fallen over, it needs to be moved, or there's a hazard. Now that could lend itself to a particular workflow, maybe another bot picks it up or another device picks it up, or it actually alerts, it's humans that it might be on site to actually deal with that as well. So it's this hyper connectivity that we're seeing that 5G is really going to drive. There's a couple of use cases that are starting to come out now, but a lot of it, to be frank, is in pilot stages. We've tested it in certain markets, specifically in the US, Germany, the UK, and Singapore, and we're working very closely with the CSPs, local and global system integrators, as well as ISVs. The ISVs are being very important to us because they're the ones who actually really develop the applications that would sit on this infrastructure and this environment and really engage with the business stakeholder.
Are you there, Chris? Hi, guys. Are you guys there?
Sorry, say again.
Chris, are you there?
Yes, I'm here.
Okay, cool. Please continue.
Okay, sorry. Thanks. So it's working through that journey map with our customers and with that partner ecosystem. It's absolutely vital for especially Microsoft, and I'd see it with any sort of hyperscaler, that partner system is actually quite vital. I mean, for instance, if I speak from a Microsoft perspective, we aren't a RAN provider, for instance, right? We're not going to go off and do a RAN assessment. We're not a telco. We're not going to start putting out and laying out a cable to our customer sites and starting up POPs there as well. But what we're doing is we're trying to take our compute, our intelligent compute, right, that has a lot of machine learning and cognitive services, and trying to bring that closer to the edge. And it's all coupled with that 5G connection there as well. So for instance, we'll go through a ideation stage with our customers, work out what their business imperatives are, and then start working out, okay, well, is it net new revenue that we're going to go for, or is it optimizing your operation? So in the case of a manufacturing plant, it also could be a health and safety aspect of it as well. So for instance, going back to the use case that I shared with you around the autonomous vehicle, let's say that forklift, we're now not relying on a human operator because there's a lot of safety issues they're concerned, but we're now relying on technology and data to drive that vehicle around and actually be aware of its surroundings. And in that way, we can actually ensure that there's less risk to humans. So you could actually reduce your personnel's footprint on that site. I mean, for instance, we'll take like a manufacturing plant, there could be 200, 300 folks in there, and actually reduce it to about 10 in a fully autonomous manufacturing plant as well. So with then taking that human capital and then elevating it to different areas of the business, especially when information technology is concerned as well. I do also want to sort of touch on sort of that feedback model around intelligent powered edge. So it's not just gaining insights and getting those intelligent insights, but it's intelligent action back in. So for instance, we're working with an organization in Australia, and they'll have a flue stack. So there's a big chimney, right? And an individual will walk up that flue stack, up a flight of stairs, and in protective gear in 40-degree heat sometimes, because it's Australia, right? And they'll walk all the way up there, and it'll take about a good 30, 40 minutes, maybe even an hour. They'll take a sensor reading with a sensor stick, capture that data, and walk all the way back down. Now, if we're able to embed an IoT device there, as well as an actuator. We could actually close that vent when it's not needed. We could see if there's blockages, etc. as well. So it's this nice feedback model as well. And you want to kind of instantaneous, right? And again, that's where 5G will really lend itself. It's at low latency, high bandwidth, and we can then drive actuators where they need to be driven as well. I don't know how we're doing for time, but I'm actually just going to cut it short there, and then we can have sort of any Q&As at the end. So hopefully I'm giving some time back to the rest of the folks.
That was brilliant. Appreciate that, Chris. Let's take the Q&A towards the end of the session. We have another last two speakers to go, and let me introduce 𝗦𝘂𝗽𝗽𝗃𝗽 from Birmingham, United Kingdom, to present on the integrated security for telco cloud edge.
Yeah, thank you, Kanish. Thank you, everyone. So let me share my screen.
Fantastic.
Okay, great. So just a quick introduction. My name is 𝗦𝘂𝗽𝗽𝗃𝗽𝗽. I'm working for Airtel Networks as a head of technology and solutions. I'm mainly responsible about the solution engineering and architecture for our telco and large service provider customers. So I'll be talking today about understanding the security threats for telco edge and private 5G. So I think most of the speakers touched on how telcos and enterprises are realizing the need to move toward the edge and deploy edge and cloud services, right? And this is mainly to leverage the massive or advanced advantages of the 5G. Multiple, of course, benefits such as high speed, low latency, and even other benefits that will definitely drive new revenue opportunities and business models. So as we can see here on the slide, there are different types of edge computing: device edge, enterprise edge, mobile or network edge, as well as cloud edge, right? So both CSPs and enterprises are definitely exploring the new use cases to deploy edge and bringing contents and application closer to the users and IoT devices. Now, this will definitely meet the ultra low latency and high bandwidth requirements, as well as enhancing the customer experience. I believe Kanish touched on these use cases at the beginning of the session today, and covered some of these use cases, including the interesting study for even other use cases, including video and the cognitive analytics use case. So by bringing the contents closer to the users, we'll save the bandwidth on the transport network and will also optimize network infrastructure, right? And with mobile, also with mobile edge computing, the 5G core function, for example, the UPF, could be deployed as a microservice in an edge site of the CSP network or private data center of the enterprise network, or even it can be in a public cloud such as AWS, Microsoft Azure, or Google Cloud. So although 5G comes with the embedded security standards, but it also introduces potential security risk that are associated with the deployment model and the communication systems. And the shift to the edge and deploying edge cloud services and enterprise private or hybrid private 5G networks introduces new security threats that are mainly associated with 5G and edge deployment. Some of these potential security threats, as we can see here, are with 5G deployment in hyperscaler cloud platform, the HTTP2 and exposure of API, inter-PLM and roaming potential security, open run security risk. Of course, today we only have 10 minutes, so I will be covering one of the security risks associated with the 5G deployment, or very specific to the edge, which is the DDoS-based IoT botnet. So we talked about some of the security risks, and even though there are some security risks associated or with previous access technologies such as 3G, 4G, but these risks are mainly associated with external attacks. However, with 5G, edge computing, the IoT architecture, these risks, let's say, security threats becomes larger and more serious. So the 5G core and the edge side can be attacked from the internal networks. So basically, it's an inside to outside approach, considering the 5G provides high-speed internet broadband, a massive number of consumer and IoT devices, and this can be considered as a new point of attack for the 5G edge architecture. Now, the impact of security compromise on the CSP or the enterprise edge network could be massive, right? Because edge sites normally have less capacity than central or core sites, and it hosts even critical or latency sensitive applications, mainly to accommodate low latency requirement, including IoT use cases. So if you think about it, for example, the impact of a 10 gig or 20 gig volumetric DDoS attacks could have a major impact to the network availability and even impact the low latency requirement. That will definitely lead to a surface interruption and brand damage. So this is just an example of one of the recent IoT, DDoS-based IoT botnet. So I think it's important when we think just to clarify one point here, when we think about IoT, people might think about very special or industrial IoT use cases, but that's not always true. Because if you log into your broadband modem at home today and see the number of connected devices, you might be surprised with the list of devices as we can see here on the picture, right? So a lot of devices connected to the Wi-Fi, and most of these devices have limited computing resources to provide any security functionality, and typically they are not securely coded, I would say. So in this slide, we see an example of an IoT botnet called 𝗦𝘂𝗽𝗽𝗍. It is a DDoS-based or DDoS-focused IoT botnet that utilizes a large set of remote code execution to leverage vulnerabilities in IoT devices. Now, these IoT devices, again, could be network gateways, CCTVs, DVR, and other type of IoT devices at our broadband or at our home, connected to our home broadband modems. Now, once the IoT device is successfully infected, The botnet use protocols and applications, TCP, UDP, and HTTP to send and receive configuration updates and attack commands. The infected IoT nodes will then begin generating a DDoS volumetric attacks or traffic, leading to a massive or sudden spike in the UDP traffic. And we're talking about this specific botnet that will continue or will send a lot of traffic going back and forth with the peer-to-peer networks. Now, the question here, can we enhance the security of the IoT devices? So even though it is always recommended to keep the IoT devices running the latest firmware with all security patches applied, however, we cannot rely completely on securing or updating the IoT devices, right? And therefore, the network should always be equipped, or the edge at the edge side should always be equipped with the modern security solution, and also leveraging new techniques like AI, machine learning, to protect against all type of DDoS attacks, including zero-day attacks. Also to mitigate against any large-scale amplification attack or low-volume persistent attacks. So to summarize, the shift to cloud and edge is an evolved approach to deploy and deliver services and introduce a more dynamic environment for CSPs and enterprise. However, the security measures in place today are not really aligned with the cloud edge requirement. So if we think about it from, if you look at this from different point of view, like for example, footprint for physical security solutions, it cannot scale at the edge site with such a footprint or physical footprint. Operation complexity and lifecycle management with an increased number of edge sites. Also from form factor to align with the cloud native strategy for moving to the edge. All these capabilities will have an impact on the TCO as well. Now, the security for edge and the cloud must be measured carefully to align with the increasing and the new potential security threats, as well as also ensuring the CSPs and enterprises achieve their business outcome. This requires securing the mobile packet core infrastructure, deploying modern network protection to, again, deliver the mission critical application at the edge, while also maintaining the low latency requirements. Also, the security implementation for telcos should consider security as a service. So some operators today are even exploring to offer secure IoT services, leveraging network slicing, for example, right? And provide flexibility that will provide the flexibility for end customer to manage their security policies with the complete network isolation. Such capability require security integration with the 5G ecosystem, and the security solution cannot be a siloed deployment anymore, right? This will ensure subscriber and device awareness to provide even more agile security control.
Hi, Adil. Would
So
you be able
this
to
is
repeat?
yeah. This is actually the end of my presentation, and thanks again, 𝗃𝗃, for the invite. It's back to you.
Thank you, Adil. I think that was a great explanation. Appreciate it so much. So to the last speaker, let me introduce Gábor Foldes from Budapest, Hungary, to present on can investment of MNOs and big tech's contribution to 5G investment? Over to you.
Hello, good afternoon, everybody. Okay, everybody, can you see my screen?
Yes, sir.
Okay, thank you very much. So first of all, thank you very much for the introduction, and thank you very much for the opportunity. It is a real honor for me. And I would like to speak about mobile network operators and big tech hyperscaler companies, competition and cooperation, and focusing on the cooperation part, which is a co-investment into the public cloud. So I am an economist and I'm a PhD candidate on the Budapest University of Technology and Economics, and I work for the telecommunication regulator, the National Regulatory Authority in Hungary as well. So I will speak as the last speaker from the economic part of 5G and 5G related technology shifts that we have heard in the previous presentations. So I will focus on the total economy level impact, a little bit social welfare, and then the telco part, so the mobile network operator side, how it looks like. The purpose of my presentation is to resolve a conflict between the mobile network operators and big techs, because they are fighting for the customer ownership, to whom belongs the end customers, and definitely the financial impacts, to whom pays the revenues, the customers to whom pay firstly the revenue, and who has to make the necessary investments, CapEx, I mean the 5G rollout. So you may know that I will show later a little bit that the data increase that we are seeing nowadays and forecasted by Ericsson Mobility Report in the upcoming years, it is generated mainly by the hyperscalers, and they are monetizing it. So why the investments, the CapEx I spent by the mobile network operators. So this is a kind of conflict situation that reaching a serious debate in the European Union currently. And therefore my research question was that what is the optimal form of cooperation between the hyperscalers and the mobile networks operators? How can hyperscalers contribute to the 5G rollout? And the hypothesis what was taken, it is coming from the official European Commission approach, which is showing or suggesting a kind of direct financial contribution, a so-called fair share or fair contribution that it is expected from big techs towards the mobile network operators. And the expected findings of my paper is there is another kind of contribution opportunity if the mobile network operators and hyperscalers set up a kind of co-investment model via the public cloud, which might be the first step to contribute, to give contribution from the hyperscaler side to the mobile network operators. So it is a kind of indirect financial contribution, which is enabled by the technology transformation that ongoing currently. So let's see a little bit to see that what does it mean competition, what does it mean cooperation. Competition means, you can see above this graph, it is about the share prices from 2017, how it has changed. The black shows the big techs, they were increasing heavily, while the telcos, the red one is a kind of flat or slightly decreasing. So it shows the difference, how the evaluation changed in the last few years. And so there is a cutthroat competition for direct customer relationship, to who owns the customers, to whom pays the revenues, and where the profit come up. So it means the revenue-related profit, the EBITDA, or compared to the investments, compared to the assets, it is the ROCE. Corporate valuation, the stock exchange value, and enterprise value per EBITDA, it is also a very important point and very important difference between the companies. And these are the financial indicators that showing that how attractive for the companies, for the investors. So investors, private equity, this is also a field of competition when these two big company groups are fighting for the investors and cash. However, there we see a lot of cooperation among them, because what we have seen also today in the previous presentations, there are Mac solutions, so edge computing solutions, which are to some extent related to the hyperscalers. Even if it is happening in the public cloud, it is much more related. So the cooperation reason to reach cost efficiency from mobile operator side, productivity, and instead of private cloud, to leverage on the efficiency gains of the public cloud, it is crucial. And it is relevant also not only for the radio segment, but also the core segment as well. What we can see that there are many relationships. So big telco groups has more than one hyperscaler connections. So many cases, what you can see in the middle of this chart, that the incumbent telecom operators like British Telecom, Deutsche Telekom, Telefonica, Orange, or Vodafone are leveraging all of the three key players. Definitely, these players, I would like to reposition themselves and get a better role in the whole value chain. Let me speak a little bit about this technology trend. The driver is the data traffic increase. It is said by Ericsson that the CAGR at 24% is expected to till 2027. And let me summarize the Sandvine report of the current usage of current split of the data traffic among application categories, application groups, and then even application. So video streaming, social networking, these are the crucial usage which are generating traffic on the global average. And the application groups are Google, Facebook, Netflix. These are responsible for the majority of the global traffic. And what you can see here, that altogether these top 6 application groups are responsible for almost more than half, almost 2/3 of the global traffic. And this is said by the European Commission or argued by the European mobile network operators, that the data traffic is generated by these application groups, these kind of hyperscalers, and therefore they expect a kind of financial contribution. And if we move to the right side, what we can see, it is the technology shift. In the RAN segment, we have heard many parts. I just would like to run through. So this disaggregation is one of the enabler, hardware and software disaggregated, but also the BBU to centralize and distributed units. Virtualization is ongoing. The network function is virtualized. The network is software defined, becoming, and the radio signal processing, it will be in the cloud. So these are the main trends that enable that hyperscaler can step into the traditional telco market, and one part of the capex investments do their own side and bring their public cloud, a kind of product into the whole value chain. And this is, on the other hand, on the mobile network operator side, it is a kind of savings, it is a kind of cost efficiency. So this is the reason why mobile operators are open for this kind of co-investments, because the 5G related costs requires cost efficiency. In Europe, it is said that in the digital decade 2030 program, that 100% of the households should be covered by the broadband network, 1 gigabit broadband network, and also 100% of the population should be covered by 5G at the time. It is said that without further contribution from hyperscale side, the mobile network operators should almost double their investments in the upcoming 7 years to reach that target, and it's almost impossible. So the current CapEx intensity, it is around 15% in the European telecommunication industry. And in the last few weeks, there was a survey that said that almost 30% CapEx to sales should be spent per year in order to reach only from the mobile network operators funding this European digital decade 2030 targets. So therefore, an efficiency is needed, cost efficiency is needed from many sides, mobile network sharing, tower cooperations, Open RAN, it is also a kind of lever of the savings, but now the focus is on the hyperscaler cooperation, this public cloud investment opportunities. Here is a kind of slide. Here is a slide that summarizes the main industry forecasts, how the financials will go in the upcoming years, and what are the main financial trends, and what is this mobile network operator and hyperscale co-investment can contribute. It is said that the total OPEX in the telecommunication industry, it will be flat or probably might slightly decrease. However, the network-related part will increase and reach and will exceed the 50% share of the total OPEX. It is interesting, but it is said that the CapEx compared to 2019 in 2027 will be might be a little bit lower, even more than 20% lower, and it is coming from these kind of cost efficiency measurements, so cooperations, network sharing, tower co-involvement, Open RAN, and also the hyperscaler co-investments. So these are the key levers that should be taken into account when we would like to flatten the investments or even decrease it. And if you see that what is the 5G related CapEx share, then we can see that it will increase. It is from out of the total CapEx of an integrated company, fixed and mobile included. Then the 5G related CapEx will increase from last year 40% to more than 60% in 2027. And what is also important that out of the 5G CapEx, the most important part, the most costly part is the radio segment. Out of the radio plus core CapEx, it is said that 87% will be related to RAN in 2025. And it is still a kind of a prediction that compared to the traditional in-house solutions, the vendor-related investments will have even bigger dominance. The vendor share from the CapEx will increase from 60% to 73% till 2027. And it is important because the vendors are bringing kind of ready solutions and kind of standardized solutions. They can sell it for wider audience. Therefore, the prices might be lower, and it might be easier for the operators to decrease CapEx and decrease investments with using vendors outside solutions. And what is also important here it is the virtualization related spending. So for run segment, it is the future that the radio segment will be virtualized, and it is said that it will increase the virtualization related capex by 1/3 in this period. If you see the vRAN cloud, then it is a little bit over 30%, and vRAN software and other services, it is 36% increase. So these are the trends that are expected from financial perspective of a mobile network operator side, and what we can see that cost efficiency activities are really important and needed. And it is the final statement here, which is in a red bracket, that the public cloud related TCO savings can be 25%. So if hyperscalers are involved into this journey, then it can result at 25% savings, which is an amount that should be taken into account as a kind of hyperscaler contribution to the rollout, because the mobile networks operators could solve with private cloud or with traditional way, much more expensive way that compared to the public cloud offered by the hyperscalers. So the conclusion is that yes, there is a debate currently in Europe. The dispute is over that how to finance the digital decade 2030 program, how to reach this 100% population coverage, and who pay this projected 30% capex to sales. And the answer is that a kind of co-investment, a kind of market conform solution needed, which is a mutual benefit resolution for the hyperscalers and the mobile networks operators. So it is a kind of first step towards the fair contribution of the 5G rollout investments, if they do together co-invest, and it allows them to share the investment costs. So the technology trend as disaggregation and virtualized RAN and core networks, as well public cloud opportunity, is the enabler. So it helps to do it. The first mover were the challenger MNOs, the challenger MNOs. I mean, in the US, Dish, or in Europe, it is said in 1&1 Drillisch, in German operator, who is doing a kind of greenfield investment, greenfield open run, which also include public cloud solutions. And it is followed by the incumbent MNOs, because everybody see that this is the future-proof trend of the investment, and this is the way to reach cost efficiency in order to deliver expected profits like EBITDA, and gain better valuation on the stock exchange, and gain the attract of the investors, private equity, who put money into this industry. And so in order to limit the total cost of ownership, the TC of the network, efficiency is needed, and public cloud can contribute up to 25% savings. So this is the main approach from my side, compared to the fair share question, which is not easy to deliver, because net neutrality principle not allows kind of financial contribution of the spending, and also not in line with imposing tax. So it is a rather political question. So otherwise, it would be unclear which big tax on what baseline should pay, and to which MNOs and how to allocate among the MNOs. So this kind of fair contribution principle sounds good, but it's not a market conform and not easy to deliver and roll out. Thank you very much for the attention.
Thank you so much, Gabor. I really appreciate it. That was fantastic. It was really insightful. So let's move on to the last. Let's move on to the last session. Let's give us about 10 minutes to have a Q&A. All the speakers are feel free to question any of the speakers presentations. Let's have a quick 10 minutes just to see what are the things that you want to ask or you want to get clarification. All the speakers are still around. Okay, maybe I can start the first question. I think it's very favorite question. There was one analyst from US have actually asked me or messaged me yesterday, and he was asking the #1 challenge and opportunity for CSPs is 5G monetization. And while 5G adoption is going well, without a 5G premium, are there cost savings for CSPs to move the traffic from 4G to 5G? Right. So my direct answer was very simple. Is not all about total cost of ownership. It is a total value of ownership, because at the end of the day, it's not about savings money, but how you can make or generate revenues based off that investment, right? Because as I know that, even during the beginning of the 4G deployment, maybe about 10 years ago, in the early stage, 4G had some issues, strong competition with the OTT players, because OTT players just came in the market and they were dominating. And that's where, the 4G was, they had to find some new ways of how they can make those revenues. So maybe, I don't know, Gabor or anyone on the floor who want to take it up and to answer this.
I'm happy to have the first stab at it.
Yeah.
So you're right. So I think a lot of traditionally the telcos have sort of missed out on that value stack, right? Like other players have come in and sort of taken that apart. What I'm also seeing is that there's a lot of infrastructure investment, so CapEx investment by the CSPs to put out this infrastructure, right? Especially around 5G. So you're seeing some native and non-native 5G deployments, and they want to see the return of that investment. Now, like with Microsoft, for instance, we're helping around the network virtualization aspect, so making it a little bit easier and more digestible for the CSPs to sort of roll out that side of things. But yeah, I think again, it's sort of we're partnering up with the CSPs to make sure that they unlock that value. And I think it's incumbent on the hyperscalers to now do that. I think in the past, we weren't really that active in that space, but we're really trying to sort of drive that partnership as well. I mean, for Microsoft, for instance, I don't know if you've seen with AT&T and also Verizon, we're investing quite heavily in that area to support the CSPs. And basically, it's joint go-to-market, right? It's joint product development as well. So we're really trying to like drive that partnership as well. And I see that happening with other hyperscalers as well. So it's good to see that we're stepping up and supporting the CSPs in that motion now.
Yeah, I just wanted to add, even 4 years ago in South Korea, like South Korea Telecom, they were leading in the Asia Pacific when it comes to the telecommunications deployment since the days of 2G. And 4 years ago, when they started to deploy the 5G itself, they are willing to invest $10 billion US dollars. I think they are the one of the only player or really aggressively going all out in comparison of US. Yes, US and some operators in Europe, but in this region, Asia They are the only one who really can go all out, because they know that their customers are ready to enjoy or to use such of killer apps, particularly in the area of augmented reality, virtual reality, and metaverse applications, NFTs as well. So I think the consumers are more matured compared to the other part of Asia Pac. So I believe the SK Telecom took that risk of investing huge amount to deploy the 5G network without expecting any returns. So it took them 4 years after, and they haven't even reached the break even. But they know that sooner or later they can able to make more revenues out of it.
Yeah, I mean, here in Singapore, right, Singtel's done a huge investment. I think also with 5G, it's slightly different from the 4G deployment, right? A lot of 5G was, at least the use cases are driven by
Did I lose you, Chris?
I think he's breaking. Yeah.
Okay.
Oh,
Sorry, Chris.
okay.
We lost out you.
It's okay. So I've just moved, so my Wi-Fi is a bit spotty. So I think, yes, I was saying that I think a lot of the difference between 4G and 5G in a lot of the markets is the governments were initially investing in proof of concepts, where 4G, that was very much driven by the CSPs. And the government agencies are always looking for connected ecosystems, like connected ports, connected airports, trying to really bring these metro environments connected, right? So I think a lot of that is still happening with a lot of investment by governments. I mean, I was seeing it here in Singapore, like you said, in Korea, I was seeing it there, Japan as well, and Australia. There's a lot of investment coming from government entities to say, hey, CSPs, there's a lot of initiative here. Let's get 5G rolled out because we see the benefit, which is markedly different from what we've seen in the past. So I think 5G adoption, my feeling is, yes, it's a little bit bumpy at the moment, and I think that's a supply chain issue. But I think once that's sorted out, we're going to see probably a hockey stick over the next 12 to 18 months of adoption. Sorry, I have to drop. It was a pleasure connecting with everyone. Thank you again for the opportunity to present. My LinkedIn profile is, hang on, there.
Yep.
So yeah, so please feel free to connect with me.
Fantastic. Yeah. Right. So I think thank you so much for everyone. I really appreciate for today's presentation, and let's keep in touch. It's a small work, and the video will be ready and uploaded on YouTube in the next couple of hours. Keep in touch, and thank you so much for your time and opportunity. Have a nice day.
Thank you, 𝗃𝗃. Thank you, everyone.
Thank you. Bye.
Thank you.
Bye-bye.
Bye.
Bye.